Do you ever watch crime shows like CSI and wonder how accurate they are? One of the most popular forensic techniques depicted on TV is blood spatter analysis, where investigators determine the source of bleeding and reconstruct the events of a crime based on the location and characteristics of bloodstains. But how does this actually work? Is it all just made up for dramatic effect? Or is there some real science behind it? But before we get into that, let's talk about the difference between spatter and splatter. The point of convergence is basically the point where the blood droplets converge or come together. This can help investigators figure out where the blood came from, because blood always travels along a straight path until it hits something and changes direction. When an object strikes a surface, it creates a small explosion of blood droplets. By measuring the angle at which the blood droplets hit the surface, investigators can figure out the angle of impact. Generally, the smaller the droplets, the more force was involved. They can also analyze cast-off patterns. Cast-off patterns are created when a weapon is swung in a circular fashion, like a baseball bat or a whip. These patterns can help investigators figure out things like the speed and direction of the blow, as well as the size and weight of the weapon. Blood doesn't always behave the way you'd expect it to, and there are a lot of factors that can affect the accuracy of bloodstain pattern analysis. For example, if the blood has been cleaned up or contaminated, it can make it harder to interpret the pattern. That's why bloodstain pattern analysis should be used in conjunction with other forensic evidence, like eyewitness testimony or security footage. It is also important to note that bloodstain pattern analysis is highly subjective and requires a lot of experience and training to interpret the patterns correctly. That's why it's important to have more than one analyst. Look at the evidence. That's because more force means that the blood was traveling faster when it hit the surface, which makes smaller droplets. It requires a lot of training and experience to interpret the patterns correctly, and it should be used in conjunction with other forensic evidence. But when done correctly, it can be the key to solving a crime. So next time you watch CSI, remember that there's a lot more that goes into bloodstain pattern analysis than meets the eye. Hopefully, you learned something new, and maybe even a little bit cool. And as always, thank you for watching. Blood pattern analysis software like Chemispat can help analysts simulate different scenarios and see what bloodstains would look like. Analysts can also use a stringing method to find the point of origin. This involves putting strings or wires on the floor at the same angle as the bloodstains on the ceiling. The point where the strings intersect is the likely area of origin. Another cool tool is a 3D laser scanning of the crime scene. This creates a point cloud, which is basically a 3D model of the crime scene. Then analysts can put bloodstain patterns into the model and see how they would look from different angles. So by analyzing the size and shape of the droplets, investigators can get an idea of how much force was involved in creating them. They can also use trigonometry to figure out where the blood came from. Here's how. Let's say you have a bloodstain on the wall, and you know the angle of impact. You can use trigonometry to figure out how far away from the wall the blood source was. In this case, we're going to use the sine rule. So if we know the angle of impact and the length of one side of the bloodstain, we can figure out the length of the other side. And that'll tell us how far away from the wall the blood source was. So by using trigonometry, bloodstain pattern analysts can basically reconstruct the crime scene and figure out what happened there. The size and shape of those droplets depend on the amount of force applied and the distance the blood travels through the air. In general, the greater the force, the smaller the droplets. And the farther the droplets travel, the more they spread out. That's because once the blood leaves the source, it's no longer under the influence of the force that created the splash. Instead, it's only affected by gravity. So, as it travels through the air, it slows down and eventually falls to the ground in a predictable way. So if you have 2 or more bloodstains on the wall, for example, and you draw lines from the edge of each stain, the point where those lines intersect is the point of convergence. Once you've identified the point of convergence, you can use trigonometry to figure out the angle of impact. The angle of impact is the angle between the line of best fit of the bloodstain and the horizontal plane. In other words, it's the angle at which the blood hit the surface. To calculate the angle of impact, you basically take the arctangent of the opposite over the adjacent sides of the bloodstain. So if the bloodstain is tall and skinny, then the angle of impact will be close to 90 degrees. If the bloodstain is short and wide, then the angle of impact will be close to 0 degrees. Because when I first watched CSI, I thought they were using these terms interchangeably, and that is not how the cool kids use them. This is basically the area where the blood came from. So by analyzing the point of convergence and the angle of impact, investigators can figure out where the blood came from and how it got there. Kind of like a 3D blood puzzle. Spatter refers to the blood droplets that are created when an object strikes a surface with moderate force. Think of it as the blood equivalent of splat. On the other hand, splatter describes the blood droplets that are created when an object hits a surface with a lot of force, usually over 100 pounds per square inch. Basically, think of it like this. If the blood is just kind of splattered around everywhere, then it's splatter. But if it's more of a spatter, it's just spatter. Got it. Good. Let's move on. In this video, we'll explore how bloodstain pattern analysis is used in real life and what exactly the science says about those blood drops falling so dramatically off of knives and guns and people and walls. Generally, there are three types of bloodstains: passive stains, transfer stains, and projected stains. Passive stains are drops created by gravity alone, like if someone was dripping blood from their finger. Transfer stains are created when a bloody object comes into contact with a surface, like a handprint. And projected stains are created when force is applied to the blood, like blood being expelled from a gun or from a person who's been shot. Bloodstain pattern analysis is a type of forensic science that involves interpreting the physical characteristics of bloodstains to help piece together what happened at a crime scene. It helps answer questions like, where did the blood come from? How fast was it moving? And how far away from the source was it projected? In short, blood spatter analysis can provide important clues to help solve a crime. Now, bloodstains come in all shapes and sizes, depending on how they're created. Now, when we talk about blood spatter, we're really talking about projected stains, because those have a lot more information encoded in them. There are two key pieces of terminology to know when it comes to blood spatter analysis: point of convergence and angle of impact. Using this information, investigators can also figure out the area of origin. Okay, so now that we have all that lingo down, let's talk about the physics behind it all. Now, here's where trigonometry comes in, but there's more to it than just that. The size of the droplets can also tell investigators something about the force that created them. Now, this is all pretty basic stuff for blood spatter analysts. Analyzing all this data can be pretty complicated, but luckily, there are some tools to help. Now, despite all these fancy tools, it's important to remember that bloodstain pattern analysis is still an inexact science. In conclusion, bloodstain pattern analysis is a powerful forensic technique that can help solve crimes, but it's not as simple as it looks on TV.